Okay. Hi
Hi,
guys.
good afternoon. Let the students join one by one, no problem. We'll start the session.
So in the previous
So, in
session,
the previous
we have
session,
talked
what
about
we have done is we have talked about the machine learning and their
first
basics, right?
process of the
And
machine
the
learning
first process of the machine learning is nothing
and
but
data
the
extraction.
data collection as well as the data pre-processing or data processing, whatever we can say. So,
Then
there,
what we are
what
talking
we
about
are
is
talking
we have
about
to
is we
collect
have to
the
collect the data
experience
first of all that is going to
information as an
represented as an
experience.
experience,
And then
and
after
then
that
after
is
that
going
it is going to be the
is going
then
to
it
be
is going to be
processed. So
processed. So
what I was
what I
referring
was
to
referring to there is like
is
in
the
the data
process of
processing, even we have mentioned about the null
unvalued.
values and so on so stuffs there, right?
So if
So
you
if you
say
say, if
just
you just
consider
consider
this,
this is a data set, and
sorry,
sorry,
this is
this
the
is the
Titanic
Titanic
data
data
set.
set. You can download it from the Kaggle website. I'll talk about that in a while.
So
So
now,
now, Now
here
here,
if you
if you
see
see, this is the
some
sample
data
data
set
set that
we
we
are
are
considering
considering
as
as
per
per
now.
now.
And
And
here
here,
you can see
you
that the
can
entire
see
row is
that
filled
the
and the entire column
entire
is
row is
filled, but
filled
here you can see some
and the
of the
entire
missing
column
values,
is
right?
filled, but here
So
you
these
can
are
see
all
some
called
of the
as
missing
missing
values,
values
right?
or the empty values,
So
or we can
these are
say
all
whatever
called
the
as
term that
missing
we have.
values, or
This is
the
also
empty
called as
values,
null
or we
values
can say
also.
whatever the
So the
term that we have.
jargons may
This
different,
is
but the
also
very
called as null
very
values
basic
also.
concept is
So the
there
jargons
there
may be
is
different, but the
just
very
we don't
very
have
basic
any
concept
values over there,
there is
whereas
just we
the
don't have
entire column is
any
mentioned
values
for
over there,
something
whereas
else.
the
Okay,
entire
this is
column is
one thing.
mentioned for
And
something
another
else.
thing what we have
Okay,
done
this
is we
is
have
one thing.
talked about
And
the
another thing
quality
what
of
we have
data.
done is we
So
have talked
once
about
we
the
are
quality of
talking about
data.
the
So
quality
the
of
once
data,
we are talking about the
here
quality
as
of
I
the
mentioned
data,
before itself,
here, as I
the entire
mentioned before
field
itself,
will be
the
having
entire
some
field
data type, but
will
the
be having
particular
some
fields will
data type,
have the
but the
another data
particular
type.
fields will
Very good
have the
example
another
is
data
the
type. Very good
ith
example is
column,
the
which means the
ith
ticket column.
column, which
Here
means the
you can
ticket
see
column.
that the
Here you can
majority,
see that the majority,
in the
the
numbers,
majority are in the
whereas in
numbers,
between those
whereas in
strings
between
it
those
is being
strings
added
it
with
is being added
some
with
characters. So
some characters. So
altogether it will be
altogether it will be
converted as a
converted
string.
as a
So
string.
but we
So,
need
but
it
we
in the
need it
sense
in the
of
sense of,
we
I mean,
need it
we
in the
need it in
sense
the
of
sense of, I
in the
mean, in the
numerical
numerical
data
data
type.
type.
So
So
there,
there,
and one
and one
more
more
thing,
thing,
we
we
have
have
talked
talked
about the
about the
relevancy
relevancy
of the
of the
data.
data.
So
So
the
the
relevancy
relevancy
of the
of the
data
data
here,
here,
this
this
data
data
set
set
is
is
to
to
predict
predict
whether
whether
the
the
passenger is
passengers
survived
survived
or
or
not.
not.
Which
Which
means
means
that
that
we have talked about, we
we
are
are
going
going
to
to
predict
predict
this
this
column.
column.
The
The
breathe
breathe
column
column
is
is
going
going
to
to
be
be
the
the
predictor.
predictor.
For
For
our
our
convenience,
convenience,
in
in
many
many
places,
places,
what
what
we will do is we will just make the predicting column as the last column. So let me take let me take a brief introduction about the data at
the
this time.
data
Then we can
at
enter
this
one by
time.
one, so that you
Then
can
we can
identify
enter
how the
one by
computer
one, so
vision
that you
can be
can identify
adapted to
how the compute vision can be
this kind of
adapted to the
scenarios.
this kind
Now,
of scenarios. Now,
when we concentrate on this,
when we
just a minute.
concentrate on this, just a minute, I will open.
Yeah, this will be very convenient. Yeah.
Yeah, this will be
Now,
very
if you
convenient. Yeah.
consider this,
Now, if
we
we
do
consider
have
this, we do have
yeah, we do have
yeah, we do have
these
what is
kind
it?
of
We
features
say
that we
these
have.
kind of features
Okay,
that we
so
have.
here
Okay,
we have
so
to
here
predict the
we have to predict
survive.
the survive.
So I'll make this as
So
the
I'll
last
make this
column.
as the
Okay,
last
here
column. Okay,
individual, I think
here
you can understand
individual, I
what is
think you can
happening there.
understand what is
Here
happening
P
there.
class is
Here
one of
P class is one of
I mean P
the,
class is
I
one
mean
of the
P class is one of the.
P class is one of the
P class is
column
one of
and
the column, and
followed by the sex and
followed by the
followed by
sex,
the
and
age
followed
and
by the
followed by the
age, and
SIP
followed by the
SP
SIP SP,
and
and
batch,
part, you say, yeah,
batch
part,
and
and
ticket
ticket,
and
and
fare
fare,
and
and
cabin and
cabin, and
embark and
embarked, and
survive.
survive.
Okay.
Okay.
Now
Now
here
here
I am
I am
going to
going to
change the
change the
color
color
for
for
the
the
predicting
predicting
variable
variable
alone.
alone,
Just
and
make
just
it
make
as
it as
red.
red color.
So
So
okay.
okay.
Now
Now
these are
these are
now
now
going to
going
be
to
the
be the
features that
features that
are
are
given to
given to
us,
us,
and we
and we
are
are
going
going
to
to
predict
predict
this.
this.
Okay.
Okay,
So
so
how
how
we
we
can
can, I mean,
how
how
we
we
can
can
identify,
identify,
or
or
how
how
we
we
will
will
usually
usually
represent
represent
the predicting
predicting
variables,
variables,
or
sorry,
sorry, not
not
predicting
predicting
variables.
variables. How we I mean,
How
how
we
we
usually
usually
represent
represent
the considered
considered
features
features
are,
are,
we'll
we'll
use
use
it
it
in
in
X.
just a second.
Use
Use
it
it
in
in
X
X
suffix
suffix
one.
1.
Okay,
Okay,
followed
followed
by
by
the
the
name
name
will
will
be
be
in
in
the
the
place
place
of
of
X
X
suffix
suffix
2.
2.
X
X
suffix
suffix
2.
2.
Followed
Followed
by
by
X
X
suffix
suffix 3, and
followed
followed
by
by
X
X
suffix
suffix
4,
4,
followed
followed
by
by
X
X
suffix
suffix
5,
5,
followed
followed
by
by
X
X
suffix
suffix
6,
6,
followed
followed
by
by X suffix
7,
7,
followed
followed by X
by 8,
8,
followed
followed by
X
X suffix
suffix
9, and followed by X suffix 5.
Okay, now we have mentioned how I have shown that how we are going to mention each and every column, right? Instead of having the x, y, z as separate variables, we are going to suffix or use the suffix for, use the suffix for the notions, and then the end one is nothing but the predicting variable that will be mentioned as y. It will
It
be
will be
mentioned
mentioned
as
as
y
y
suffix
suffix
1.
1.
If it is
If it
going
is
to be
going to be
more than
more
one
than one
predictor, it
predictor,
is
it is
obviously
obviously it is
going
going
to
to
be
be
the
the
y
y
suffix
suffix
1,
1,
y
y
suffix
suffix
2,
2,
y
y
suffix
suffix 3,
3,
so
so on
on,
it
it
will
will
be
be
done.
done.
So
So
the
the
p
p
class
class
considered for
considered
the
for the
x1,
x1,
name
name
considered for
considered
the
for the
x2,
x2,
and
and
sex
sex
considered for
considered
the
for the
x3, and
x3, and
age
age
considered for
considered
the
for the
x4,
x4,
and
and
exit
exit
SP
sp
considered
considered
for
for
x5,
x5,
and
and
so
so
on.
on.
So
So
let's say
let's say
I'm
I'm
not
not
digging
digging
into
into
deep
deep
related
related
questions
questions
like
like
XP
XP
and
and
stars
stars
and
and
something
something
like
like
that.
that.
So
So
I'm
I'm
just
just
going to
going to
give
give
you
you
some
some
of
of
the
the
gist
gist
related
related
to
to
the
the
relevancy
relevancy
of
of
the
the
data.
data. Okay.
We are
We're
just
just
gonna
gonna
discuss
discuss
about
about
the
the
relevancy
relevancy
of
of
the
the
data.
data.
So as
So
we
as we
have
have
mentioned
mentioned
before,
before,
this
this
relevancy is
relevancy is
nothing
nothing
but
but
what I
what
am
I am
going to
going to
predict.
predict.
I am going to predict, the predicting variable is going to be the survive. Okay. So then, and the
The
features
features
that
that
I am
I'm
going
going
to
to
consider
consider
are
are
these
these
features,
features,
and
and
we
we
are
are
just
just
gonna
gonna
look
look
into
into
the
the
logic,
logic,
and
and
then
then
we'll
we'll
come
come
across
across
with
with
it.
it.
We
We
are
are
not
not
going
going
to
to
do
do
any
any
mathematical
mathematical
equations
equations
over
over
there.
there.
Let's
Let's
say
say
this
this
P
P
class
class
is
is
nothing
nothing
but
but
the
the
passenger
passenger
class.
class.
Depending upon the passenger class, the survival rate can be increased. Let's say if you consider the scenario, this is the Titanic data set as I said already. So if you consider in this way, let's say the top floor of the ship, the passengers at the top floor of the ship can be regarded as like P class 3 or P class 4. They can get out of the cabin and then they can enter the lifeboat easily. So that I'm guessing that I can identify, or I can it is somewhat sensible to have considering the P class. So X1 will be, that means the P class will be considered for my feature, considered as my related feature. Whereas the name, depending upon the name, we cannot do anything, right? So it will be rejected. So I'm just moving on with the logic. I'm not doing it in any mathematical sense. Usually in the industrial standard, or if you talk about any nomenclatures, it will be done using the correlation or something else. So
So
I'm
I'm
just
just
going to
going to
give
give
you
you
the
the
gist
gist
what
what
is
is
related
related
to
to
the
the
relevancy
relevancy
of
of
the
the
data.
data.
There and one more thing, the sex, which can be a male or female, right? So at that occasion, I'm just taking a guess that like in the human mentality, the girls or the female gender will be allowed for the first one will be allowed for enter the lifeboat, right? So if I guess in that way, if that happened, I'm not sure whether it happened or not, but I'm just doing it by my guess. So if that happened, the female
Who
who has
has
escaped
escaped
will
will
be
be
the
the
more.
more.
Okay,
Okay,
so at
so
that
at that
occasion,
occasion
we
we
have
have
to
to
consider
consider
this
this
the
the
X3
X3
as
as
an
an
important
important
factor.
factor.
So this factor sex is also considered for as the important factor. And next thing is age. So similar kind of stuff. I'm just considering age. Age is nothing but like age is why I'm considering the age is if it is a born child, it will be with the mother, and consecutively, if it is going to be mother who is having this child, and they will be allowed for the life both. So there you can understand the X3 and X4 can be combined together in some scenarios. I'm not I'm not mathematically saying, I'm just saying the guess. Okay? So the combined attributes are, yeah, combined attributes can be attributes like x3 and x4 can be combined together, right? So in that case, what happens? Combined together, one single attribute will be used instead of those two attributes, 6.3 and
And
6.4.
6-4.
It will be combined, and if, instead of those two, it will be it will be replaced with another new attribute. So how we are going to combine? It can be either the linear model, or it can be a non-linear model, whatever the combinations that we have. So even I have given you the some of the gist regarding this kind of attribute relation. Like I think in mapping, not it is in the segmentation itself. I think I have talked about that. What is the thing is one minus alpha into B plus alpha into B. Sorry, alpha into H. Sorry, F. So here the thing is depending upon the alpha, the foreground or foreground or the background will be visually, and it will be highly visible, right? So some kind of scenario like this, having one constant like alpha, we are going to prioritize what factor it is going to be. So it can be linearly combined like this, or we can say some non-linear combinations like y is equal to f of x. Sorry, y is equal to x square, or some polynomial equations. It can be combined in that way. So there is a chance of having an attribute combinations over there if the tool, as I said, so if that condition was satisfied. And regarding the rest of the things is going to be considered, and we etiquette and fair everything. So this is how the relevancy of the data will matters. Okay, and here depending upon the predicting variable, we have done so and so stuff. And in many data sets, you can come across with this quality check that you will have the null values. I mean, we call it as NA values or null values like this, and you will have the attribute data type mismatch like this. So these are considered as a noise also. Okay, so I think I have briefly talked about those stuff. And then, now, as a first step in the machine learning, even in data analysis, even in data mining, the very first step is we are concentrating on the data visualization. So the data processing and data, it is coming under the first process itself, like data collection and data processing, right? So it is coming under that the topic itself. So what is this data visualization? Is you have to visualize and you have to, embark what is there in the attributes of the data set. So if you say the age, let's say if you consider the age, you by seeing this alone you cannot come a conclusion what is the real range or real values under this, because we have as many rows as possible because of satisfying the third thing called the quantity of the data. So higher the quantity of the data, higher will be the accuracy, right? So depending upon that, we have nearly I think 10,000 rows. I think so. Uh, yeah, it has 892 rows. So for traversing to the 892 rows manually, and then we are going to get a conclusion like that. So it is going to be a big issue. So we need some representation to be to be there for enhancing those processes. For having that, for using that, we have data visualization techniques. So that is why we are having data visualization. So there, if you see, there are many data visualization tools or data visualization techniques we can use, but we are going to use we are going to see very few aspects of them. The first one we are going to talk about is central tendency. So everyone will leads to one data visualization type is called as 5-point box plot, and goes by we will talk about the scatter plot, and I think we have discussed about the histogram earlier. So there also the frequency plotting, histogram is something related to the frequency plotting, so we can identify from that topic itself. So now, here we are going to talk about the central tendency of the data. So if you see the central tendency, the central word itself, we can identify that there we will mentioning the two kind of things, sorry, three kind of things. One is one is going to be mean, median, and mode. Okay, mean, median, and mode. So here mean is nothing but you know that it is going to be the sigma x by n, right? So in that case, what you will do, you will just add, you will just add all the numbers and you will divide it by the number of count. Okay, let's say I'll just give you one example over there.
I can give you one thing to insert here. Let's say a student in a class of students, let's say 10 persons, right? 10 persons we are going to consider, and we are going to consider only one subject. Okay, the first student, let's say he is going to obtain 50 marks. Okay, and another student is going to obtain 65. Another student will get obtain, let's say 10 marks. Another student will get obtain, let's say 35. Another student again 50. Another student is going to obtain, let's say 50. And another student will obtain 60 plus, 60. And then we can say, yeah, we can say, let's say another student is getting 100. Another student is going to get 62. Let's say it is going to be the difficult exam. Let's say I'm just imagining this situation. That's all. So I think here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Roughly we have 10 values, and if you add this, it is going to be the average is going to be 52.7, right? Let's assume this. So without here we are having 100 count, right? Instead of this control, let's say some person is having 60. Okay. So what happens here? You can see that it has been varying it has been varying like four values. So just because varying the one value, it is becoming 48.7. Whereas if you say, let's take the same scenario. Let's say we make the 62 as something like 30. Okay, we make this as 30. Yeah, okay, let's try this. And you can see that it has been varied till something like three values. So you can see that it is affected by the outliers. So we call this as like we have one more important term which is called as outliers. Even we have discussed about this. So the outliers are all nothing but, let's say I'm having a sequence of data like 2, 3, 4, 4, 5, 6, let's say again 2, 3, and 5, and 9. So I'm having this kind of stuff. At the last, I'm having 100, and again 1 and 4 and 5. So here you can see that this 100. Here you can see that, right? This 100 is an outlier because everything is in the range of 0 to 10, whereas this is in the extreme opposition. So if you do a calculation like this, let's say let's just take the same example here: 2 plus 3 plus 4 plus 5 plus 2. 2 plus 3 plus 5 plus 9 plus 100 plus 1 plus 4 plus 5 and divided by 10. Okay, so it is affecting that 14.3, which is almost higher than the range in which the rest of them are. Okay, so if I have an outlier like this, the mean, if I represent it by mean, you can see that it has been affected by the larger values. So which means that it is affected by the outliers. So you have to much more concern about the outliers also. Okay, so I think I have told about the mean. So if you say, let's say, I can give you one more scenario with respect to the advancement of the mean. Let's say the same scenario. If I say a subject one has been calculated and the mark one here, okay, there a student is getting. Uh, no, not like that. Okay, here we can say subjects. Okay, subjects. Let's say we can have M1, okay? And then we have English one, and then we can have physics, and then we have chemistry, and then we have CT, and then we have some engineering techniques or something like that, some paper like that. So you are going to consider the marks. Okay, so here I'll just mention the credit here. So the credit is nothing but here for maths, let's say 4, and E1, to say English, I'll just have 3, and P, which is physics, I'll just have 3, and chemistry also 3, and computing techniques, let's say we have 4, and engineering techniques we have 1. Okay, so here, let's say a student is getting a grade of 8 plus, or I'll just have as 5 to 10. Okay, a student is getting a mark one as M1 as 6, or let's say I'll talk about a very good sense. 10. And in the English, they are getting, let's say, 7. And in the physics, he or she getting 6. And in chemistry, 7. And CT, let's say 10. And ET, again, he's getting, let's say, 10. Okay. So I'm just going to consider two scenarios more. Marks 2. This is nothing but different students. Let's assume that it is going to be the different students. And here, let's say you are going to get it here like 6. Okay. So the rest of the things are going to be the same. Okay. Let's assume this scenario. Okay. And yeah. And we are going to talk about the marks of the third student. Let's say he's getting 10 and 7 and 6 and 7 and 10, and he's going to get the least grade in the ET. Okay. Now we are going to have a scenario like this. So here, how will you evaluate the grade? You will multiply this 4 with 10, right? So similarly, you will do it for the rest of the things. So you will have it by 4 into 10 plus 3 into 7 plus 3 into 6 plus 3 into 7 plus 10 into 4 plus 10 into 1. So divided by the total number of grades or the total grades that we have. 4 plus 3 plus 3, 10, 13, and 13 plus 5, 18. So it is going to be 18. So he is getting the CGPA or GPA as 8.33. Okay, the same thing here, but only thing we are having difference is 6 here. Okay, so instead of the 10, we have 6. So if we do it by this, he is going to get 7.44. Okay, and another thing, the same thing, but in the last one, he is going to get 6. What happened there? I think I have not added one. Okay. So 10 into 4 is going to get 6, right? So in that case, divided by 80 is going to be 8.11. So what I am trying to do here is whatever the steps that we have done here, right? It is called as weighted mean. This is one of the advancement of the mean. So here we can see that it is a weighted mean. So what you are doing here is you are giving the priority or weightage to the subjects that is being there. So that is what it has been. That is what mentioned here. So in this scenario, you can see that I have given a higher weightage to maths and I have given a higher weightage to CT. So we are just going to consider the math. So if we get a low mark in the math, you can see that the GPA is gradually decreased. If you see, if you are having a low mark in the one credit subject, that is likely or a lightly weighted subject or light weighted subject, you can see that it is not that much decreasing like of the before scenario. So this credits will acknowledge you in which subject you are going to look it upon, right? So this is how the weighted mean, the archetype scenario of the weighted mean can be described. Okay, this is how the weighted mean, right? So we have mentioned. So this is how we can get the idea of the weighted mean. And one more thing, as I told already, the mean will be affected by the outliers. Okay. So the median is nothing but the central element. If I have 1, 2, 3, and 4, and 5 in ascending order, then the central element is going to be the median one. So we have a strong relationship between the mean, median, and mode. So I'll talk about the mode and then come for the relationship. Even we have a relationship with respect to the blend curve also. So in the mode, let's say we have unimodal and bimodal and multimodal curves. Like what is this mode is the number of, the element that is the frequency of the element, let's say frequently occurring element. We can say it in a frequently occurring element. Let's say here in this sequence, you can see that the 5 is occurring for 3 times, and 2 is occurring for 2 times, and 4 is occurring for 2, and 3 is occurring for 2 times, right? So here the mode of the mode is going to be the 5, most frequently occurring element. Let's say I have a scenario like I'm just including 2 also. Then it will become mode will become 5, 2. That will be a 2 mode. So if it is going to be the single mode, it is going to be the unimodal. If you are going to have 2 modes, it is going to be the bimodal and multimodal, so on with respect to the count of the modes that you have in your data set. Okay? And the relationship between these central tendencies like mean, median, and mode is going to be the mean minus median is equal to 3 cross mean minus median. Okay? Oh, sorry. It is nothing but mean minus mode is equal to 3 into mean minus median. So this will be the relationship between the mean, median, mode. And we are going to talk about the important thing is called as quartiles. Okay? The quartiles are nothing but a given, the given data set. It is not constrained to the Gaussian curve itself. It is common for all the data set, but just for the understanding purpose, we have taken like this. So the quartiles are nothing but the 3 point. I'll just explain one by one so that you can identify. The quartiles are nothing but 3 points, 3 equi-spaced points. Okay, equi-spaced we can say that concern. So that equi-spaced point, or let's say 3 points with equal difference. They will mention in the word like equal difference. No problem. 3 points that equally divide the data set. Okay, equally divide the data set into 4 parts. So you can see that Q1, Q2, Q3 are the 3 points, and that will divide the data set into 3 parts. Okay, so that is what it has been mentioned here. The first quartile will be occurring at 24.65%, and second quartile will be the median. So the second quartile and the median will be the same at this symmetric curve, and then Q3 will be there. So the entire data set will be separated like this. So in this scenario, what it will be there is that is one more term called IQR. So IQR is nothing but the interquartile region. The interquartile region is nothing but the Q3 minus Q1. Okay, the Q3 minus Q1. So it is called as interquartile region. So these were about the quartiles, and these mean, weighted mean, and quartiles and all important for the data visualization purpose to understand the data set distributions very well. So, and next thing is skewness of the data set. The skewness of the data set is nothing but how the data set is skewed. Like it is possible, you can identify how you can see it from the curve itself. So the first one is symmetric data set where the mean, median, mode will present at the center line. Whereas in the positively skewed, the mean mode will be at the left, and then it will become, and then median will be there, and then mean will be there. So if it is a negatively skewed, the mean followed by the median, and then followed by the mode. So these kind of scenarios will happen when when you talk about the skewness. Next thing is the most important thing here. Our things are coming across, which is nothing but 5-point box plot. Okay, so here you are going to understand, or you can observe 5 points, like 5 points in the sense. The first one is going to be the interquartile region. So the interquartile range, which means the Q3 minus Q1, that is going to be the there you can say that Q3 can be identified and Q1 can be identified, and median, which is nothing but the Q2. As I told already, it is going to be the Q2. So the Q2 will be, it will be observed, and then it will be followed by the maximum and minimum values. Okay, so it will be the maximum and the minimum values. So the 5 points we can observe from the 5-point box plot. And how to implement in Python? It can be implemented using the matplotlib. And the rest of the two slides I'll talk about. Yeah, rest of the two slides are like what all the exercise that we are going to face it. Okay. So now we'll just have a small implementation session and then go for the topic of this session. So now the first thing we are going to talk about is the just a second. Alright, okay. Now here we are going to use Python. Now, here what we are going to use, we are going to use the NumPy package and the matplotlib and the pandas. As I told already, the pandas you have, which has higher importance with respect to the data science in Python. So now I'm just going to save the file as a PNG file. That's why I'm using npl.use. If you don't need, you can also suppress it. You can just leave it, no problem. Doesn't matter. So now, which is a matplotlib.pyplot as PLT, and then followed by I'm going to read the CSV file. Usually the data will be represented in the CSV file, or it will be represented in JSON, or it can be represented in XML, or it can be a database itself, a database file, DB files, MariaDB or MongoDB, or we can say any kind of DB in that sake. So for reading the CSV file, we can use read of CSV file, and we are going to do that. So after reading this file, as I told already, we have to fill the nullified values, or which is present as the empty values that I have shown before. So for that purpose, we are going to do it like filled with the mean value. So we are going to fill the values with respect to the mean. Okay. So now if you see, let's say I'll just come one by one. The thing is, I will read the file and you can see the same thing. Here you can see NaN values, right? So these are all like not available numbers or not available values, and you just need to fill those with the mean value. Okay. So if you see the data, I'll talk about why it is not been filled there. I'll talk about why it has not been filled. Just a second. So this value has not filled because of this presence of the string data type. So we are talking about the mean. We are not talking about the we are not talking about any string functions over there. Okay. The age values also we can see. Okay, just a second. Okay, no problem. I will discuss what is there, and everything will be discussed in a minute. Now what we are going to do is, let's say we are going to take the age list alone, and then we are going to make it happen. So I mean, we are going to plot age versus P class. So that's right. We are going to take the data to plot. The first column is going to be filled with age, and second column is going to be filled with P class. Okay. So you can see the data to plot will have the values. Okay. So here, since we are using the pandas, the indexing will be done by this way. So date of that square bracket itself in a call the column. So now we are going to plot the figure, and I'm just moving on. I'm using the subplot as I have mentioned before. As I mentioned in the before sessions. So
Now I have used the box plot here, and then I'm going to save the figure. That has been saved in the name of fig1 dot png. So you can see that.
So
Here
here
you
you
can
can
see
see
this
this
line
line
is
is
there,
there,
right?
right?
The
The
box,
box,
there
there
is
is
a
a
large,
large, I mean,
there
there
is
is
a
a
big
big
box,
box,
right?
right?
The
The
first
first
line
line
is
is
going
going
to
to
be
be
the
the
Q3,
Q3,
and the
and the
lowermost
lowermost
line
line
is
is
nothing
nothing
but
but
the
the
Q1,
Q1,
and the
and the
center
center
orange
orange
line
line
is
is
nothing
nothing
but
but
the
the
median.
median.
So
So
which is
which is
nothing
nothing
but
but
the
the
Q1,
Q1,
Q2, and
Q2, and
followed by
followed by
the
the
Q3.
Q3.
And
And
this
this
small
small
bars
bars
you
you
are
are
seeing,
seeing,
right?
right?
These
These
are
are
the
the
maximum
maximum
and
and
minimum
minimum
values.
values.
The
The
lower
lower
one
one
is
is
the
the
minimum
minimum
value,
value,
and
the
the top
top
one
one
is
is
going
going
to
to
be
be
the
the
maximum
maximum
value.
value.
And
And
the
the
circles
circles
that that has been mentioned here, right? So these are all the outliers that has been present in the data set. So here, if you see comparative, it has been compared with respect to the age. That's why we cannot visualize, because you can see here it is of 3, 1, 2, something like this. But here you can see that it is 30, 29, 62, 15, 29, 0.83. So these many things are there. So if you see, I mean, inside the data plot, if you see just,
I mean, data set of um,
you
you
can
can, I mean, you can use not this actually. You need to know the data set. Yeah. If we
make the
make the
fat
fat
column
column
as
as
like
like
this.
this.
Okay, even
Okay, even
I just
I
wanted
just
to
wanted
show
to
you
show
that
you that
in the
in the
seventh
seventh
column,
column,
sorry,
seventh row,
you
you
can
can
see
see the
the null
null
value,
value,
but that
but
has
that
been
has been
filled with
filled with
the
the
mean
mean
value
value
using
using
the
the
fill
fill
NA
NA
function.
function.
And
And
here,
here,
since it
since
has
it has
been a
been a
string
string
data
data
type,
type,
we
we
have
have
not
not
used
used
anything.
anything.
It has
It has
been
been
not
not
filled
filled
with
with
that.
that.
Okay, so
So
now
now
we are
we are
just
just
going to
going to
have a
have a
box
box
plot
plot
for
for
the
the
fat
fat
alone.
alone.
So
So
here you
here you
can
can
see
see
just
just
calling the
calling the
fair
fair
dot
dot
values
values
will
will
lead
lead
to
to
the
the
values,
values,
and
and
to
to
list
list
is
is
nothing
nothing
but
but
uh, to list is for
to list is for
making it as a list conversion.
making it as a list
Then,
conversion, and then
so you can see it is
you
being
can see
converted
it has
as a
been converted as
list,
a,
and then
list, and then
using this you are going to
using this you are going to
plot the
plot the
data like
data
this.
like this.
So again, the
So
figure one
again,
has
the
been
figure one has
saved.
been saved. So I have not meant to, I have not made any changes there. That's why it doesn't, it is reflecting. Just a second. So instead of having a subplot, instead of having the subplot, if we use the plot function itself, it can be worked out.
Right. Okay.
Right. Okay. Okay. It's 220. Okay.
So we have
So
to
we
move
have to
quickly.
move quickly.
The
The
second thing
second
is
thing is
creating a
creating a
data.
data.
So this is
Oh,
for
this is
another
for
box
another
plot,
box
and
plot,
this is
and
for
this
the
is for
scatter
the
plot.
scatter plot.
I'll just
I'll
move on
just
to the
move on
scatter
to
plot,
the
and
scatter plot, and I will leave rest of the things to you, and I will share this code file in the
classroom.
classroom.
So I have
So
used
I have used
AGG, so I
AGG,
can
so I
only
can
save
only
the file.
save the
I
file.
cannot
I
show.
cannot show it happen. Why I have not imported this? And then numpy, and then we'll go for the scatter plot.
So you can
So you
see
can
the
see that
scatter
the
plot.
scatter plot,
You can
you can
express
express
why
as y.
you can
You
make it
can make it
happen like
happen like
this.
this. Okay.
So
So using
this is
done
done
using the
using the
function
function
called
called
scatter
scatter
function.
function. And
And
similarly,
similarly,
you
you
can
can
use
use
the
the
scatter
scatter
matrix.
matrix. The
Scatter
scatter
matrix
matrix
is
is
nothing
nothing
but
but
having
having.
I'll
I'll just let you know with respect to this. So you can see the scatter matrix. Usually, this center column will be null. Since I have given as a, since I have given as a histogram function over there, diagonal is equal to this. So the histogram has been definited. So what you have to need to understand here is A versus B. What is the scatter plot? A versus C. What is the scatter plot here? So each and every scatter plot that has been possible inside the data set will be visible over here. So in the diagonal element as a principal diagonal will be filled with the histogram of those two things. Like it is going to be the frequency table over there. So now this is how the formal visualization of the data set or data can be done. So here we have seen the box plot and we have even okay, this is for like how to generate the line chart. So this I'll just stop here. So this is nothing but how to arrive at the sine function and then sync function. We have talked about the sync function already, right? Yeah, sine x by x. So this is the sine x by x np dot sine of p1 divided by the p1. So the range is from 0 to 30.0. It should jump from the 0.1. This is what the constraint that we have given. And for that we can say we can get the value as the top is called a sync function and the second one is called as a cast function. As you know that at the zero value the cast value will become 1.0. So it has been mentioned like that. You can see the changes here at the 2 pi and everything you can see. So this is how the this is how the plotting usually done and data visualization done in the industry even for any problems that we are talking about. So PLT plot will use for the plot function will be used for the plotting the line chart, and even we will use some of the other data visualization tools like heat matrix, or we will talk about let's say. The smiley diagrams, and there are a lot many visualization techniques are there with respect to the with respect to the data set that you are considering. If you are going to be the string data type, we can have separate data visualization tools, and if you are going to consider the numerical, the DOS plot can be used, so on so stuff can be done related to the data visualization. So continuing on that, we are going to talk about the linear models. Okay. So in this session, we are going to briefly discuss about the linear regression. Okay. The linear regression is nothing but it is a straightforward approach for predicting a quantitative response. So you have to understand the basic difference between the quantitative and qualitative response. So as I said already, the quantitative response will be related to the float or any integer. It can be something like related to that. So the numerical, the quantitative response or the quantitative variables coming under the numerical attributes, whereas the qualitative, when we talk about the qualitative response, this will come under the categorical variable. So here we are going to talk about the simple linear regression, and as we proceed on, we can go for the multiple linear regression. Here, whenever we talk about the linear regression, it is going to be, as I mentioned, so it is going to estimate or it is going to get some quantitative response. The basic generalized model of the linear regression is going to be the y is equal to beta naught plus beta 1 x. Here, beta naught and beta 1 are going to be the coefficients or the parameters. And here you can see that beta 1 is purely related to the, it is purely related to the slope, and beta naught is nothing but it is purely related to the, the intercept. Sorry, the intercept. So here you can see that we are going to estimate the values of beta naught and beta 1. So how we are going to estimate it? That is what the main criteria is.
So I'll just give you the gist what is the practice, and then we can go on with the new methodologies and so on so stuff. So what they will do is they will initialize with the new values of beta one and beta naught, and it will be increased further or decrease in some direction. So there we are going to use the probability distribution in order to which values we have to choose. There we will use I mean, there we will use the Gaussian distribution, as well as we will use some other distributions also for estimating those values. And here, the main theme is going to be the reducing the residual sum of error. This is the error calculation for the linear regression models, which is nothing but RSS. RSS is equal to E1 square plus E2 square, etc. to En square. So E1 is nothing but the modular difference between the yi minus yi cap. Here yi is nothing but the original value or the value that you have to get, and y cap is nothing but the value that has been predicted. So this e value, e base I is called as ith residual. So residual is the nothing but the remaining part, right? So which means that you have to make it happen. Like your model is increased by this way, or the model is decreased by this way. We can get the information from the residual variables. And y cap, as I said, so y cap is the predicted value of the designed model. So next thing is estimation of the parameters. So as I said, so I have told you that we will start with the initial value and then we will start with the estimation, right? So here the estimation is done using the sum of squares itself. So that is being displayed here. So here you can see this has been derived. This beta one and beta not beta naught. The beta one has been derived after some mathematical calculations. Then only we can arrive at this position. So I have told already that it is something similar to the slope. So you can see y1 minus y2 divided by x1 minus x2 also. So from that concept also we can derive the beta one. But in many scenarios it is not advisable because of like you will have infinite data points, and there will be a lot of outliers, and depending upon many situations, a lot of it is not outliers, and depending upon many if you do like that, situations, it will lead to the it is not advisable. So even if you do like that, if you do like that, it will Acadism is nothing but it is based on one principle called KISS. So Acadism's razor. So this principle is talking about the overfitting of the data. So there we will talk about keep it so simple. Okay. So for that concern, we want to make much more complicated curves for fitting the data. So here SE is nothing but the standard error. So by having the derivation, the standard error of the beta naught has been calculated as sigma square into 1 by n plus x squared by sigma xi minus x bar the whole square. And even the standard error of the beta one, which is nothing but the slope is equal to sigma squared, right? Sigma and then summation over 1 to n into x of I minus x of I the whole x bar the whole square. Where you can see that x bar and the y bar are nothing but the mean values. Okay. This is how the mean square will look like. So we will have a data points like this, and we will draw a line in such a way that in the way that the line is being derived from this concept. Like it is estimated by the beta one is equal to and beta two is equal to that formula, and then it is being drawn. So here, since the model we are talking is linear regression, so we cannot make curved lines like y is equal to x square or y is equal to x cube or y is equal to some further powers like y is equal to x power 10 or something like that. So we cannot make like that. Even the log exponentials and so on so stuff are there, right? The aspect curves and so curves are available for the nonlinears.
So we cannot use because of we are constrained towards the linear models. So assessing the accuracy. So we have to assess the accuracy. So in that case, we are going to use the three things. One is going to be the residual standard error that we have seen in the SC, right? So that is the residual standard error. And then R square, it is one of the statistical measure. I'll talk about it in the just a minute. So IX statistics is another one assessing metrics for the accuracy. So here, the residual standard error is the standard deviation of the residuals. Smaller residual standard error means predictions are better. So, which means that error function that we are mentioning before. So, which means that E1, EY, E2, E3, etc. Here the residual is talking about that one. The E1, E2, E3 we have mentioned there, right? So that occasion we have mentioned that y minus y cap. So, which means y cap is nothing but the predicted value. So this is called as residual. So this talks about the residual. So since I mean residual error will if the RSC is very low, this is called as RSC, that is called as RSS. So that is I mean that is called as residual sum of square. It is called as residual standard error. So now this RSC is if it is low, it is going to be the predictions are better. And R square is the statistical measure of how close the data are to be fitted to the regression line. So, which is something related to the coefficient of the determination, something like whether the line is attached to the points, like it is somewhat nearer, or it is giving a very negligible variance to the or standard deviation to the given data point. So it is going to calculate in that way. So R square is a statistical measure of how close the data are to be fitted in the regression line. So it is also known as the coefficient of determination, as I said. So, and coefficient of multiple determination for multiple regression. We'll talk about that multiple regression in a while. So F statistic is the variation between the sample means and the variation within the samples. Okay, this is coming under the F statistics is coming under the sampling theorem, and it will go on further. So this is also coming under the testing, hypothesis testing also. F statistic is the test statistic for the F tests. So I'm not digging into what all the mathematical concepts over there because we are not. I mean, we are running short of time. So I'm just moving forward. In general, an F statistics is the ratio of two quantities that are expected to be roughly equal under null hypothesis. I'm just giving the gist. There is a null hypothesis. Another one is going to be the null hypothesis is called as H1 or H0 as per the book syllabus. Another one will be called as H1. So null hypothesis we call it as H0, and other hypothesis we call it as H1. So there we will do the hypothesis testing and come across with the F statistics. So now, as for now, what we have seen is we have talked about we have talked about the linear regression, that is simple linear regression, where we are talking about the x is going to be the only single variable, and y is going to be the single variable. So it is something related to the two-dimensional graph that we are seeing here. So it is related to only the two-dimensional data. There will be a one feature, and another one is going to be the predicting feature, as we have discussed in the data session. So consecutively, if you move on to the multiple linear regression, there you will come across with the more than one variables. Like you can see here, like x1, x2, x3, etc. to xn. So you have n dimensions over here. Beta naught is going to be the bias, or we can say it as an intercept, whatever the word that is convenient for us. We can say, whereas many people will say like bias. So it is the terminology that has been arised from the neural network. We will talk about that what is with my bias in the upcoming sessions. Now, this multiple linear regressions, I mean,
For this multiple linear regression, we can transform the linear regression to the multiple linear regression by adding the more and more, more and more slope constants. Like if you imagine this in your mind, like we have n dimensions and you are going to draw a linear line over there. So you have to concentrate on the all the slopes with the axis, right? You can have x, so x1, x2, x3, etc. to
xn
xn axis.
axis.
So
So
you
you
have
have
n
n
axis
axis
over
over
there.
there.
For
For corresponding
corresponding
to
to
the
the
n
n
axis,
axis,
there will be slope. So here in the before case, if you consider the simple linear regression, in that case you can see that y is equal to mx plus c. So only we have x-axis so that the m will be 1. So I mean, the only one variable, only one slope variable is needed. Whereas in the multiple linear regression, you can see that the data set itself having the more than one variable. So we are concerned about that slope also. So right from the each variable will be coefficient. The coefficient will be made as the slope of the corresponding axis, like beta 1 into x1 plus beta 2 into x2 plus beta 3 into x3, etc. to beta n plus x, beta n into xn plus beta naught. So, like instead of fitting a separate linear regression model for each predictor, a better approach is to extend the simple linear regression so that it can directly accommodate the multiple predictors. So, and one more thing here, you cannot expect a single variable of y. It can also be a y1, y2, y3, etc. Yeah. Okay. And this is done by giving the slope coefficient in a single model. As I told already, this is going to be given with the slope coefficient, so which is nothing but the beta 1, beta 2, beta 3, etc. to beta n. Now, initially, random small values are assigned to the parameters. Then, on repetition, the parameters are estimated in such a way that MSC is reduced. There we have talked about the RSC, right? Residual sum of residual, sorry, RSC, right? Which is nothing but the residual standard error. And here we are going to talk about the, sorry, here we are going to talk about the mean squared error. So which is nothing but MSE. In practice, the estimation lead to the minimization where objective function is the error function. So as I have told already, the estimation is going to be the minimization problem. So I think I have discussed about much more things about the minimization problem in the previous session, like using the gradient descent, we can perform the minimization problem, like moving the gradient towards the opposite side. It will leads to the minimizing the function. At one point, you can feel that, or you can identify that that is going to be the not inflection. Yeah, you can say you can identify the minimum value, local minimum or local maximum. So here, and one more thing you have to notice that is in that occasion in the gradient descent algorithm, I think you guys from so many of them are from Andhra also. So okay, I think you have studied Rolle's theorem in your 12th standard. Rolle's theorem. If for some conditions f dash is equal to 0, then we can obtain the local maxima or local minima at x is equal to 0. So that is a reflection of the Rolle's theorem. Even we have Lagrange's theorem and then we have mean value theorem, right? So these kind of theorems are not just theoretical or mathematical topic alone. So this is nothing but somewhat the implementation of those or application of those. So how we are going to apply in the industry or how we are going to apply in our algorithm. Okay. So here. Right, we are going to discuss one of the important topic called do all variables from the x1, x2, etc. to xn need to involve in the regression. So you can see that increase in the variables will increase in the time computation for estimating the beta 1, beta 2, beta 3, etc. to beta n. So I mean slope coefficients. So in that occasion, you will come across with the reduction of the variables. So which means that it is often the thing is that I'm saying keeping often the dimensionality reduction. So at that occasion, what you have to do is you have to do the variable selection method will be used. So those variable selection is nothing but you are going to select those variables depending upon the criteria like higher correlation or higher correlation or higher let's say, line of test or whatever whatever the criteria that we are fixing. So depending upon that, we will do the variable selection. For instance, variable consideration is two. Let's say we are going to select two variables. There are four models are possible. How we are saying four models are possible is the model containing no variables, y is equal to beta naught. That's all. And another one model will be like a model containing x1 only. So y is equal to beta 1 into x1 plus beta naught, which is nothing but a simple linear regression. Then we can go for next model like model containing x2 only, which means that y is equal to x2 into beta 2 plus beta naught. And model containing x1 and x2, as we have seen before that y is equal to beta 1 x1 plus beta 2 x0 x2 plus beta naught. So by selecting the two variables or two variables itself, we can identify four different models. If we have mentioned, if we have taken any if we have taken any three or four, it will be keep on increasing. So you can see that x1 and x2, there is an x1 and x2. You can see that there will be, there are four models, right? So it means that it is a subset. So it is being treated as a subset process. So subset process, for that process, how you will do? You will do it by 2 power p. So if p in the number of variables is going to be the p, it is going to be represented as a variable called p, and the number of models that you have to verify or that is possible is going to be the 2 power p. So you have to, if you say you have 10 variables being selected or considered, you have to generate 2 power 10 models, right? So these kind of stuff, these will lead to the implementation of the computations. So we have to reduce that. So how to determine which model is the best? Like we have come across with a number of models, like 2 power p models, and now we can identify which model is the best one. So we have several techniques. We have four techniques have been identified here, and one is the McCullough CT, and second one is the ATAC information criteria, and even we will talk about the information criteria in the upcoming sessions also. So third thing is the Bayesian information criteria, and we call it as BIC. And after that, we will come across with the adjusted R square, the R square statistics that I have told you, right? So we will come across with that. So here the same problem I have stated above. If we consider the n variables, then we will have the 2 power n possible models out there. So considering that all will be become the huge problem to face. So at that occasion, what we will do to solve that issue? So we can move it for the forward selection, backward selection, and mixed selection approaches. So I'll talk about what is forward selection, backward selection in the upcoming session. So now the potential problems in the regression are like, and this is the overview of the problems that has been incurred in the regression models, like non-linearity of the response predictor relationships. Like we cannot face the non-linearity of the response predictor relationships. And the second thing is the correlation of the error terms. And third thing is obviously this is since we are the mean is considered as a higher priority, so the outliers will affect that. And non-constant variance of error terms, like it is not constant actually. So and the collinearity is also become a same issue. So according to the linear regression, it is going. Our things are not constrained with respect to the linear regression alone. We have a lot more models with respect to the regressions, like logistic regression. Another one is Fisher's. Using the Fisher's discriminant, we can identify another regressions. But for the showcasing for showcasing this alone, I am just using the linear regression. Whereas apart from this, we will have many regression models. If the time permits, you can just have a go through on. Have a go through on the book that I have given you, the pattern recognition by Bishop. So I think I'll share it in the classroom also. No worries, I'll share it in the classroom also. So there you can see lot many regression models over there. So that book is completely dependent on the mathematics. So you have to take some time to read that book carefully. So it will take some more time regarding this. Yeah. Okay, in the upcoming session, the next session, like in the 3:30 session, what we are going to talk about is we are going to talk about how to implement this logistic regression with respect to the images. Now, before going to that, I will just clarify two more things. Like if you are taking the images, right? We have talked about this yesterday also. The thing is, if you are reading any image, just a second. So there you can see, let's say, uh, if you are using this kind of IM read, sorry, Python 3. So after reading this, if you check this out, like the type of the image, so you can see that it is a NumPy array, right? NumPy ND array. So whatever the image is, instead of the features that I have mentioned here, right? So here I have mentioned about, here I have mentioned about the features A to L. We have mentioned about the features. Here, these features will be filled up with the values of, with the values of those pixel values. Like it will be become the each and every image, or the image values will become the, it will become the, it will become the single line function. Like you can see image dot reshape of one comma minus 1, you can see that it has become img dot shape. Okay, I have not substituted this. Now I'm just, this is a dimension like a 410 cross 510 into 3 dimensions. It is a 3 dimension figure. Rows are there, 410 rows and 416 rows, and followed by the 3 dimensional figure. So here, if we talk about image, one is equal to image dot reshape. Since we are using only one image, we will use a reshape function, or if you are going to use many images, it will become a flatten function. So you can use the flatten function also. So if you use the image dot shape, it will become the 1 comma 5 1 51180 680. Like each and every element will become this. I mean, it will be attached to the single element. Like if you see image one, if you try to print out image one, you can see that 104, 108, 212, 104, 108, 216, right? So 104, 108, 212, it will be like many dimension will become the single dimensional array. So this is the thing you have to, you need to focus on. So whatever the image that we are going to give, it is not simply it will be treated as an image or something like that. So it will be treated as an sequence of data. So which is going to be the like row-wise manner only it will be treated. So this is the most important thing that you have to understand before entering the machine learning applications with for CVs, like computer vision based. Like computer vision based image processing or machine learning techniques. So even I think I have given nearly 10 questions in the previous yesterday. Today also you have one more thing to handle upon. The thing is I will post the data set, the Titanic data set that I have discussed before, and then even I will post the code snippet, and then you have to make the code, you have to run the code snippet, and you have to try it on your own with the new variables, and then come up with the new types of data visualization. New data visualizations like the box plot with several variables like the P class, or with other other features. Okay, with age, with parts, or with SABSP and P class. Okay. So one more thing we can the cable. I just want to show you another one thing that.
That is a website called kaggle.com. It is completely for the data science competitions, like
how you are facing for how you are facing your this one, right? I mean, the Geeks for Geeks, or you can say Hacker Rank. You are doing for the programming interviews, right? Here, I mean,
here we are going to talk about the data science aspect alone. So here there will be a lot many data sets will be available here, and you try
with
with
a different
data
data
set
set and
and
try
try
to
to
participate in
participate
the
in the
competitions
competitions
and
and
come
come
up
up
with the
with the
solutions.
solutions.
And
And
these
these
solutions
solutions
will
will
be
be
very
very
easier
easier
when
when
compared
compared
to
to
the
the
industrial
industrial
perspectives.
perspectives.
Okay?
Those
Those perspectives,
perspectives,
I mean, industrial
industrial
perspectives
perspectives
will
will
be
be
very,
very
much
much
more
more
complicated
complicated
comparing
comparing
with
with
the
the
Kaggle.
cable.
But
But
the
the
Kaggle
cable
can
can
be
be
a
a
good
good
start
start
for
for
any,
any,
I mean,
for
for the
the
data
data
science
science
career. Okay?
have a
Leaderboard
leaderboard
and
and
have
have
a
a
topmost
topmost
leaderboard
leaderboard
with
with
that.
that.
And
Even
even
currently,
currently, I
I can
can
see
see
the
the
German
German
peoples
peoples
are
are
dominating
dominating
the
the
site.
site.
I
I
think
think
so.
so. So
So when
when
I'm
I'm
studying
studying,
the
the
German
German
peoples
peoples
are
were
dominating
dominating
this,
this, and
even
even
let
let
the
the
Palestinian
Palestinian
University
University
also
also
dominate
dominate
this
this
cable
Kaggle
site.
site.
Okay.
Okay.
So,
So
as
as
far
far
as
as
this
this
session is
session is
concerned, we are
concerned,
going
we
to
are going
conclude
to
here,
conclude
and then
here.
in the upcoming session, we will talk
And
about the
then in the
implementation of
upcoming session, we will talk
the
about the
implementation of
implementation of the, I mean,
logistic
the
regression
implementation of the logistic regression
with respect to the image classification,
with
and then
respect to
we
the
will
image
move on with the
classification, and then we
two
will move
different
on
things,
with
the
the
two most
two different
important
things
things
and two
like
most
SPM and
important things like SPM and the
decision process or decision
decision
tree.
process or
So
decision tree.
when we
So
move on to that,
when
I
we
think
move on to
that will
that,
be
I think
that will be a long session.
that will be a
Let's
long
see.
session.
Let's see.
Let's see. Let's see.
So,
So,
okay, guys, we will
okay,
meet
guys,
at
we will meet at
3:30. Okay.
3:30. Okay.
Just
So,
have a
just
strong
have a
mindset that
strong
we are
mindset that
going to
we are
spend
going
much
to
more
spend
time
much
on
more time
those
on those
topics.
topics.
So,
So,
let's see
let's
how
see
it goes
how
on.
it goes on.
Okay, guys,
Okay,
we
guys,
will
we
meet
will
at
meet at
3:30.
3:30.